Let me talk about that substation part. Okay, but before that, I just wanted to give some intro about our organization. So that is, I felt that is it's good time to talk. So just give me 2 minutes to explain about our organization. So AmperePro Engineers India Private Limited is our organization name. So like as you guys aware that this is our website, please go through that. So what we do here is basically we are into electrical design engineering. It's an engineering consultancy who handles complete electrical design and system studies. And of course, we do complete end-to-end service from the starting the design from the scratch by understanding the customer requirement, and till they commission the plant, our support will be there. That's what the complete engineering document will be doing it. That's what almost it's like full-fledged EPC, but at the moment engineering we do it only if we are focusing on engineering deliverables and the procurement support and as well as construction support. But we are not actually doing the construction support, but we are supporting for the construction as well. Okay, that's what we do, and I hope the services what we are offering it, you can already see that what we are doing it, and the industries that what we are presently serving is data center, power and energy, oil and gas, and many other industrial plants, like a pharma, something like that. All those things we are doing it at the moment, of course including substations, right? So that is one thing. Then and I need to tell you that why I am doing this. That is also one important thing. Basically, let me quickly introduce about myself as well. Okay, those who are some of you already may you know me already, but some of you may not be. You are knowing me. So let me quickly give intro. So I have I have done around more than 250 plus engineering consultancy projects across globe, like various places. My overall experience it covers predominantly EPC in nature, which means uh, complete engineering, and maybe from the feasibility study or cost estimation or uh, detailed engineering, right? Procurement point of view, like we also do procurement support, right? And we also go to the site and take data and collect the information, and whatever for the site installation, if any support or something is not, they are unable to get, or some technical field support also we are able to provide it. So this is what my total experience throughout. And of course we do power system studies, end-to-end support as well, right? So this is our my strength. Okay, so why I am doing this training program is very simple, because when I started my career, no one is there to guide me that you have to do like that. But throughout my year, I felt like we went and in a hard way, and we have learned many things which helped me to excel myself across, and I wanted to give back to those who are in the mid career or young engineers or whatever it is. So they need some guidance. That's why we are doing it. Intention is very simple, and I used to tell to so many people as well. Okay, so again I'm telling here as well, I take this as an opportunity to share this. Okay, great. So now let's go further. So so this is what I am telling, right? I have already told, no need to do that. My expertise is basically a lot of I have hands-on knowledge on IEEE and IEC standards, of course Indian standards as well. And my expertise in softwares, ETAP, AutoCAD, CDGS, of course, so many other modules as well there. That's what my a lot of my projects are, from utilities. I mean, oil and gas sectors, right? Refineries, solar plants, and substation, right? And this is what my experience. With this experience, like I'm able to give you that from where you have to start the project and how you have to start the project, what are the input you needed it, and even let's say that you're going from one project, one organization to another organization, how, like, already some projects will be running, and how you have to attach yourself and how you have to go inside and pick that rhythm. All those things we are able to give it. And if the project is completed by 70 percentage, how you have to involve himself, all those, step by step approach, and we'll be able to guide you that one thing. Secondly, when you are doing project, a lot of people, they have a lot of questions, and due to the project timelines and tight schedule, it will be always time schedule, right? I hope everybody is aware of that. We need to handle that kind of, pressure and etc. I don't think, I never take that as a pressure. I always take that as a, I'm learning something new today, because I'm getting that opportunity to learn something new. I always take like that. So that is why, but still I'm seeing that so far we have trained, almost more than 500 people actually, right? So but I see that still that problem exists. So we wanted to solve that. So that's why we are doing this training, guys, actually, right? This is what I am able to give it from my side. Okay. So when you're, you know when you're going through the entire design projects, step by step approach, no, which means you can start independently and you can lead the project independently, right? And whatever the technical questions, whatever that, when you go out for different companies, what they will ask or what they will, uh, with respect to the technical questions, you will be able to, answer, and how you have to approach the project, and how you tell or how you have to explain the projects, so that that they get more, idea about you, right? How much you have involved, the way you explain, no, they will come to know, right? So those things we can give that. That's what we are going with actually, right? So, and definitely it will give you the, if you are in confusion, definitely you'll get some clarity. From the fear to confidence, that we can bring out. Definitely, I hope a lot of you have done that, right? So that's about me. That's what my overall idea to give this course actually. So now I will go back to the substation part, guys. Okay. So what I'm going to do, I will explain to all of you, and I will add few things. Okay. So how we are going to do, I'll explain. So let's take one small simple substation, 220 kV substation. Okay. Can you guys tell me that what exactly in this layout it is actually, right? So this particular substation, this is actually 220 kV substation. Please remember that it's a 220 kV substation, and it has got outdoor as well as indoor, which means this is a GA substation, which means this is a outdoor substation, right? So which is 220 kV substation, and it this is the overall substation layout, and it has got 5 transformers. I mean, only 3 are there at the moment, 2 are for the future purpose, right? See, when you get a scope of work requirements, okay, when you get a scope of work from the your customer or whatever it is, you need to go through that, what exactly they want, right? That is a first step. Lot of people, I feel, I see that a lot of people, they are not going through the document because it will be like 1,000 page, and so many tender documents are like that only. Okay, tender documents are like that only. We need to go through it. We should not miss even single page. And I'll tell you that how to skim through it so that you can quickly see what is needed. Okay, in this course we are going to discuss like a real project, how the discussion is being made, and how we have to take the approach, and how we have to start. All those things we are going to do it. It's like a small substation we are going to design throughout this course. We always do like that only. We always do in the live only. Okay, so that's what we are going to discuss, guys. Actually, that is one thing. And you see that in this also, like let me add few hints here. You see, uh, by looking at this substation, will you be able to draw the single line diagram? Can you guys tell me? By looking at this diagram, will you be able to draw single line diagram? Or like let's say that when you take a case, you're going to the site for the data collection. You don't have anything. Customer is asking new project, right? He is telling that you come directly and do that, right? So how do you do that, right? So we will how we are going to do it? Simply he is asking you to the site, and he is telling that you see this, and I want something similar to that. How do you take? How do you start that? That's the question, right? That we will explain that how to approach. And that is the existing part. There is two things that we need to define. One is, when you are starting from the scratch any project, that is called greenfield. It's a new, because it's an open land. Let's say that you are going to build a solar plant. Nothing is there. It's an open land. So you are going to start. So how, from where you are going to put the electrical substation, how you are going to look at the incomers, all those things. Of course, your client already, or customer already, he might have seen it, but still we need to go through it, right? All those things we are going to discuss in that. And we'll take one real case, and we'll start from the scratch. We are going to build like a real project. That is what exactly we are going to do it in this case, guys. And you see, in this is a kind of battery manufacturing company. So which for that they got a company from I mean they are getting the cable from the 220 kV substation, and it is coming here. You see that this is one bay that they have allotted for that cable, and there is a cable sealing end. And after that, this is the lineup. How we are going to line up the substation? This is how you have to line up. First, you need to put the cable termination, because they wanted to have some metering equipment and etc. And there is a cable which is coming. Suddenly, they wanted to convert into overhead line. How do you do that? Because you need to put the cable termination, cable sealing kit. So then you will be cable to overhead line, you are converting it, right? Then there is a isolator, then there is a MPT, that metering this thing. Then one by one you are going to keep it, right? So again this is for the isolation purpose, nothing else. Okay, and some CTVT that you need to keep it. For that we are keeping it. Now again you are converting into the cable, you are taking into the substation, which is nothing but your 220 kV GAS substation, right? It's a GAS room. So for that, how the design is like what needs to be, please remember that GAS is a proprietary equipment by OEM equipments. Like, but see, OEM will concentrate only on their equipment, but who will design the rest of the things, right? What exactly is needed? How much? How to take the GAS equipment inside? All those things you need to look at, right? So all these how you are going to route the cable, how you are going to bring the cable to the transformer, right? So this is 220 kV per 11 kV substation. I mean, the secondary is 11 kV. So from the 220 kV switchgear, you are taking the cables out. You see that you're bringing the cables here, and there is a road we are crossing here, and we are adding into that. Yeah, it is going to the respective transformer. In this particular project, the future, like at present, this is actually 3 substations. I mean, 3 transformer. This is the HV side, and this is the LV side. Now LV side is a cable. Now again from the cable you need to take it and you have to route it to the HV switch gears. All these plan how you are going to do it. That's what we are going to discuss. And I'm very honest. This is what we do, right? This is what we do. And of course there are other factors that we need to look at. So this is one of examples, guys. Okay, so you need to create a several sections, how the equipment is coming and the cable is coming inside, and how you are converting into overhead, and how this aluminum tube, all those things is being designed, right? Then again coming back, it is going back, right? Then there is a section of substation, right? So why we are showing so many sections, how the GIS equipment is being located, and any other equipment is needed for the GIS equipment actually. So why so many rooms are required? And of course, this is one side of part. This is only layout part. Okay. Any engineer, he has to prepare single line diagram. He has to prepare specifications. He has to prepare data sheets. He has to prepare calculations. How to size this entire equipment? We need to design. We need to choose the right protections and control. Everything we have to do it, right? So for that, one must go through the Indian standards. If you are doing project in India, or else if you are doing projects outside, then you must go through it through like a IEC. You have to be very clear and thorough, right? So anyone who is working on the outdoor substations or anything above 1 kV, they must be aware of IEC 64936. This is the installation standard, power installation standard for anything above 1 kV. Those who are doing LV installation, they need to be aware of IEC 60364 for the LV system, which means it has got so many parts. These are all the stuffs from where you are taking the information, on what basis you are taking the information. With the standard, we are going to cover it. Okay, so we will give the standard snippets from where we are picking the values, how we are adopting it. So in my throughout experience, each and equipment, how it operates, on what basis they are designing it, on what standard that we must comply it, safety check, how to do that, right? Everything we are going to cover it, guys, right? That is one thing. We are going to use software ETAP, then maybe AutoCAD. Then for the lighting, we are going to use Dialex. These are the typical software. For earthing, maybe we will use CDGS or ETAP itself. That depends upon the we will use it. So please remember that you need to have some idea about softwares. Of course, that separately will take it. Okay, but this is a real engineering. So combination of theory, calculation, then both, all three combinations will be there. So this is what we are going to cover it. Point number 1. So now there are other stuffs. Maybe I just quickly, I just wanted to share some idea how we are going to look at, right? So right, the entire substation. What if there is a substation? If it is a pooling substation, what are all the things that we need to look into, right? So whether why we need AS or GS, what is the difference? We need to understand, right? right? And in the switchyard, how many equipments that you have to keep it, and what are the things typically which is needed? We need to know what are the standards typically it is applicable for a substation design. We'll do, right? So ask yourself whether we know everything. If any one of the part is not needed, then we need to understand, right? So that's what our work, right? So you need to understand the typical equipment, electrical equipment. This we call it as a electrical equipment selection and sizing. See, selection is different. Sizing or dimensioning is different. See, sizing or dimensioning is simple calculation. Anybody can do it. Once the calculation is known, you put it in Excel and type it. Answer will come. Anybody can do it. We know that in our engineering time we have done so many equations and we have solved it, right? I hope some of you, right? So but in a real time, how to choose equipment for real projects, what will be the impact of it, what is the material that you are putting it, we are going to discuss, right? If you are choosing the material, on what basis, on which standard, we are going to discuss here, right? When you are choosing the CT or PT, you have to put some, you have to specify certain informations, right? One could be ratio, second could be burden, what is the class, whether it is a protection class or CT class, and if there is a special class, what are the things that you have to mention it in the single line diagram, what information you have to show it in the single line diagram, so that what are the information which is required in the design stage, which you need to show it in the single line diagram, and that information to whom you are putting it, and what are the documents you have to prepare it for the site execution, and what are the document you need to prepare it for the, for the procurement, and what are the basic study that you must perform to do any project, and what are the basic calculation you must do that. All those things we are going to discuss it, guys. It is going to be a long session, 3 months typically, sometimes it may extend, okay? So typically the session duration is we have planned it on Monday, Wednesday, and Friday. That's a plan that we have done it. So it's like a real work. Please remember that there is no sometimes if you have to refresh, yeah, we touch the theory little bit, sometimes to refresh ourselves, okay? But most of the thing, it is like a real project. It's like we give assignments, you also do it parallel, you have to work and ask many questions. Those, when you are there during the project, you may not get answers, ask those questions here, we are here to answer, okay? So that we become more confident, so you become more confident, that is very important. That is what next level elevation, right? Great. So these are all the points that we are going to cover it, and how the substation equipment arrange, what is primary, what is secondary, what and all is covered in primary engineering, what and all we covered in secondary engineering. All those things we are going to do it, guys, right? So protection concepts, and what do you mean by protection? What do you mean by control? When you say protection, what are the protections? For what equipments you are going to give protection? Transformer, how to choose transformer, and bus bar, how to choose bus bar, and what are the different schemes are available, and for that how to give the protection. If there is a different scheme, we are going to discuss it, right? Then relay coordination, it is one of the important piece of document that you need to do it. We are going to talk about that. And of course we need a control, we need to control the electrical equipment. So how we are going to control all the equipment? Through SCADA, right? So why we need a control and relay panel? Up to what voltage you need a control and relay panel, or up to certain in the high voltage, up to certain voltage we don't need. If you give it, it is fine. Or up to certain voltage you need this. When, where, you're going to talk about, right? So when it comes about grounding, you see that grounding. So substation grounding is a very important topic. How lot of people they know that how to do grounding. That is absolutely fine. But do you know why you are doing grounding and lightning protection system? What are the standards that we are following it? If it is a substation, we are going to use IEEE 998. If it is a buildings, then we are going to use IEEE 62305. Even if it is a IS, I mean Indian standard, again it is same, number is same. So how, what are the design criteria you are going to discuss, right? Like that, so many things we are going to discuss, guys. It is not like I'll share you the syllabus here. I'll share you the syllabus here. So just give me a moment. If you guys want any specific topic, please let me know. I will add it, and just give me a moment. So still it is under preparation stage, and due to the project schedules, I'm doing it slowly. Shivaji, yeah, just give me a moment. I'll share my. This is a rough syllabus that we have basically prepared it actually, but still we are going to upgrade it. Okay, so like whatever I have added, that we are going to add more actually. So we are going each and every part and how to do and where to do. Okay, so this is for surge arresters. This is for instrumentation. I mean instrument transformers. So this is our syllabus that we are going to cover it, guys. Okay, so wave trap PLCC system, right? Isolator and earth switch. There are different types of earth switch, right? We are going to talk about that. Circuit breaker, from the LV to till EHV, what are the different circuit breakers are available? And of course, nowadays we are going to completely, remove this actually, because please, if you are doing currently, if you are doing any new system, please do not propose SF6 gas. It is completely banned. How many of you know this actually? How many? If you are already it is installed, no need to worry about it. But in any new design, we don't need to propose it. Most of the places it is banned. How many of you just put it in the chat that FT if this information is new to you? I know that a lot of people still they are proposing SF6 gas. I mean any breaker. It is because SF6 gas, it is impacting the environment. Okay, so that is why lot of countries they are banning it already. They are implementing it. Even as a replacement, there are other technologies have come up. Okay, so SF6 gas do not propose anywhere hereafter. It is completely banned. I mean because it is causing some with respect to the environment, they are banning it. Okay, so that is one thing. So we are going to talk about circuit breaker, right? Then power transformer, why we need a transformer, different windings, all those things we are going to discuss about that, right? Then we are going to like a transformer itself is a big topic. Okay, that is one thing. Then protection point of view, then grid substation, what are the bay configuration, how we are going to look at, we are going to deal, right? Then we are going to take some pooling substations, which typically in the renewables it is there. So we will talk about few stuffs, right? This is typically we have prepared, but still I wanted to take in a deeper manner. So we are making a syllabus now. Once it is ready, we will be sharing it in the across in the in LinkedIn, in our forum, wherever it is there, we are going to share it, right? So that's about the syllabus, guys. If you have any questions or if you want any specific topic to be included, please let me know so that I can catch it. Okay, so it's pretty long session actually. It will be, so we'll try our best to minimize as possible, and if in case it requires, we may extend the training as well, I mean further. So accordingly you need to block the calendar. Okay, so that is very important. So that's the part, guys, right? So any other information that you need? Some of the things there may be a theory part, some of the things there may be a calculation part, right? Some of the things you see this and all, it may be a kind of theory as well as kind of how to prepare the system architecture level we'll talk about, right? So all those things, it depends actually. So we are rearranging the syllabus. Once it is completely ready, we'll be sharing it, guys, right? So that's all from my side for today. I mean it is around, I think I have completed within 40 minutes. So yeah, like as a beginner, yeah, now you can ask questions, or maybe like I'm open to answer all the questions. Yeah, tell me, guys. So now can I get quick answer from all of you? May I know who and all is interested and to join this course, and I will let you know the price as well. And already we have already communicated. Okay, so because we can directly join, I mean visit our website. We have put the course. You can choose, and I will let you know the course timing as well, guys. Okay, that is very important. So let me share that once again to all. So any questions you can ask or doubt or anything is there, so I can address that. If you have any concerns or anything, let me know. So I'm happy to address now. So Shivaji Sekhar, yeah, we are going to kindly discuss about thermal view at substation and switchyard. Yeah, we'll talk about. Sanjana, I want to build my career in electrical design engineer. I need your guidance to start. Sanjana, please reach me out, and I will give you my electrical engineer number. Then you talk to her. Okay. So yeah, Oliver, I'm interested. I don't know for the okay price. I will let you know, guys. No worries. No worries. Yeah. Yeah, Gopinath, definitely. I will share one link now. Okay, please fill it. You will get the participation certificate. Okay, once you share that that participation certificate in the LinkedIn, you will get the recordings. Okay, whatever you'll get the recordings. Okay, great. So yeah, yeah. Thank you, Mr. Rowe. Actually. Yeah, in this entire row, we will cover that 11 kV switchgear as well. No worries. Yeah. Yeah, Naidu. Yeah, I will let you know that. Just give me a moment. Let me share the screen so that you guys can have a look. And yeah. Yeah. So go to our website. Those who are new, just visit our website. Okay. Go to our home page. You click that. This is our website actually. Come down. If you see that there is all courses, substation design online training. Okay. Click on that. Click on that. So the course is starting at 15th April, Monday, Wednesday, and Friday we are going. It's going to be a 2-hour session, but please remember that it may extend. Okay. 3 months. slowly it may extend, because some of the topics, if it requires deeper understanding, we'll go with that. Okay, that is also I am telling now itself. Okay, go through this. So to enroll, you can just click that. So like you can go through that, whatever I explained. These are the softwares I'm going to use throughout. Okay, that is one thing. And maybe and yeah, this is our course price. So whoever is joining, for them we are offering this price. Okay, so that's our price actually. Definitely it's worth of taking it. If you do this investment, you can anywhere, if you move it, you will get it in another 1 month. That's it. Very simple math. Okay, so try it. That this syllabus we are going to update it, guys, but you don't need to refer this. But what I have shared it, we are going to share it across, right? So use this. When you click that, please remember that you will see this price, but use this code, this one, that coupon code. Please remember that, use this coupon code SSD45. Okay, and like when you just click here, there is a code. Okay, use this 45, type in. Okay, then automatically the coupon code will be applied. Then you can use this Razorpay or PayPal or whichever is convenient to you, and you can buy it. Okay, this is one thing. And I'll share you one more uh, information. Just give me a moment, guys. Those who need recording of this, whatever we discussed, and so those who need records, I mean recording of this webinar, please register in this. So you will get, please register everyone, you will get the webinar participation certificate. Okay, and share it in the LinkedIn and tag us, so that we will come to know that you shared it. And for them, we will share the we will share the recordings. Only for them only we are going to enable it, those who are sharing it. And don't just share it what you have learned in this little session. Okay, so that is very important. Learning is very important. Ultimate is that only. Okay, so that is one small request from my side. Okay, and yeah, guys, now I am open for the questions. Any doubts or with respect to the course or with respect to the topic, anything, please let me know. So I am open for answers. Like I am able to answer now. You can unmute yourself if you wanted to unmute. You can unmute yourself. I guess you should be able to unmute yourself. Great. Yeah. Yes, guys. Anybody? So it's
Hi, Jay Kumar
okay.
Rao here.
Yeah, I'm good. Yeah, yes.
Yeah. I've been in the field in Bangalore for about 28 years.
Yeah, yes, sir. Thank you so much for
And
joining here. Actually,
yeah,
yeah.
yeah, we are still struggling with 11 kV, which is the most common substations around the installations. So
Okay.
let us
Yeah.
say let us say in if you have, let us say, uh, I don't know, maybe about 25 to 30 11 kV stations, then you will get 166 kV station. It's very rare,
Yeah.
and
Yeah.
very few people, very few companies can take up 66 kV. So
Yes.
I
Yes.
would not even know from my 26 years or 30 years in Bangalore, there are very few people, like a handful of people whom I know will take up 110, 220 kV and so on. So
Okay. Okay.
I
Okay.
would feel
Okay.
if you're putting up an introductory course for even a 11 kV substation, I'm sure I myself can join. I can recommend maybe about half a dozen people rather than simply jumping up to 220 kV. That's my opinion and my experience.
Okay. Like here the focus is not about 220 kV, not specific like that. I wanted to let you know now. The thing is, anything above 1 kV, we are calling it as a high voltage. So we will take one case 11 kV or maybe 110 kV or something like that. So that's the idea actually. So anything 1 kV, I mean 1 kV that we are calling it as a high voltage as per the standard. So based on that, we will cover it. I mean, we'll take different examples and we will give the ideas so that they will come to know that how to assign. So that's the idea. But I take your points, sir. Actually, maybe you are saying that even 11 kV or 33 kV, lot of questions and doubts are there. So instead of 220, going to 220 kV, you are telling that to cover 11 or 33 kV. Yeah, definitely.
No,
So
not
for
in,
that
not,
also,
sorry,
no
sir.
course.
Sorry, no. 33 kV is not, 33 kV is only in the border districts of Karnataka.
Yeah.
I would say let us call this a pilot course. Maybe you can cut down the time and the effort also and see what we can do, let us say, in maybe 6 weeks or so. Only 11 kV.
Okay. Okay.
I can assure you, I have many people who would like to refresh or even learn about 11 kV design. This includes engineers, panel builders, contractors, lot of people. I have
Yeah.
quite a good following in Bangalore after being CEO of a small company for 26 years. I speak
Okay.
from my
Thanks, sir.
my
Yeah.
contacts and my knowledge of people. Yeah.
Okay, okay. That's good to know, sir.
You
That's
could
good
take a
to know
poll. You could
actually.
take a poll. You say who is interested in 11 kV. This is the cost. This is the duration. And you put out your syllabus very well.
Yeah, thank you.
I,
Thank you,
I've
sir. Thank you. Thank
I've
you.
hardly seen any other. I've been following training courses for last about 10 years. I've rarely seen anyone who put out the syllabus so clearly.
Yeah, thank you, sir. Thank you so much.
Yeah.
Thank you
I
so
would say
much.
I would
Definitely.
suggest very strongly a pilot course for about 6 weeks or so. If it runs well, then we'll go take on from there. That's my
Yeah, we'll
suggestion to
do
you.
that, sir. We
It's
take
my
that as a
suggestion only to you.
feedback. Definitely will come up.
Thank you. Yeah.
Definitely will come up, sir. Definitely. Yeah. Any other questions, guys? Because yeah, as a completion of this, how can I join any company as an electrical engineer? Yeah, because we will give the placement guidance as well. No worries. Okay, you can practice it. We have done for so many, and we will give the guidance how to approach. And only one thing is required from your side. You need to sit and you have to do what has been asked, and you have to complete the assignment. You have to ask many questions as much as like based on your understanding. You have to ask many questions. The moment you ask questions, then definitely learning starts. Very simple. You don't need, I'm not asking you to go and read basic. No, nothing required. It's a fundamentally logically, if you think, and yes, of course, then you will automatically go back and you will start refreshing yourself. Okay, so here we are not in the college. You might have studied only theory. Here we are connecting the theory what you have studied, we are connecting it to the real world, like sir explained, right? So what you need to see as a customer requirement, that you need to able to see that. The moment you see that, automatically things will come up. Then you will start reading by yourself. You will go back to your basics. That's what we are going to teach here. Yes, you need to do a lot of homework. I'm telling now itself, that is very important. Otherwise there is no point investing this money here. Only people who are taking actions, for them it is this course is. Otherwise please do not take it and waste money. Keep that and in your mind. Great. So any other question, guys, so that I can address, or any technical questions, or any other information related to course or anything. If you want to ask any other information, if you have joining difficulties or something in the portal, please reach me out. I think contact number and everything is posted already. So please reach us so that we can help you out. And Yeah. So anything else?
Yeah. Hello, Jakumar. Rao again.
Yeah, yes, sir. Yeah.
Yeah. If you say placements, I have been doing placements here and there, mainly in Bangalore. Substation is a little comes only after. See, if I may say so, from my experience, the design always begins from the load end,
Yes,
from
yes,
the
yes,
load.
yes, yes.
Substation is a source.
Yeah.
Okay, so so I train my people saying first understand the load, start from the load end. The design and the
Yes.
work at site starts from the load side, then toward it comes towards. So I would say that there is a prerequisite for some company hiring a person saying who can do substation design. The prerequisite
Yes.
would be that that person should have had at least maybe about 5 to 8 years in consultancy line plus a little site experience. The prerequisite.
Yes.
I hope I am not
Yes,
interfering
sir.
with
Somewhere.
your course
Yeah, no,
requirements.
no.
I'm
That's
just
okay.
saying.
Somewhere. Yeah.
Yeah, I can
Yeah, go ahead.
offline I can give you about I think one, two, three, four, about 5 or 8 companies, 5 companies at least. Pune, Hyderabad, Delhi, I think etc. who are conducting courses on electrical design.
Okay.
So I'll come back to the point. If this person already has about 5 to 8 years experience in construction and consultancy, and he has done your course, I can offer you a few placements.
Okay. Okay. Okay.
11 kV, up to
Definitely,
11
sir.
kV. I'm not 220 kV is very rare. I've hardly heard it. Up to 11 kV. Yes,
That's okay. That's
you
okay.
give
That's okay,
placement.
sir. Yeah. Yeah, definitely. Happy to, really, I'm so glad that you're, helping people actually. And that's what we are also doing. Yeah, definitely we'll, like those who are joining, definitely we do our best and we'll help them to, elevate them in next level. Yeah, that is our interest. Yes, yes, yes. Yeah. Yeah, I think a lot of people are there. Only two people are talking actually. Uh, I'm expecting someone to ask questions so that I can answer it, guys. Anybody? Anyone has any questions or something? Okay, let me. From Anbu. How to select bus bar sizing in substation selection, lightning arrestor, CT, CB, isolator. Yeah, Anbu, to select the bus bar, you need to see two things. One is current. Second, you need to see it in the you need to categorize into two things. One is indoor, outdoor. If you are talking about indoor, that is inside the switchgear, that is a different scenario. Okay. Second, when it is comes about outdoor, it is a another different scenario. So here you need to see two things. One, you need to look at the short circuit. Second one, you need to look at the current. Then third one, you need to look at one more thing that you need to see, mechanical conditions. When the bus bar is outside, maybe there may be a wind, there may be a icy, conditions, different climates might come. So those forces, what will happen with that? So you need to look at. So there are some more advanced, sag and tension like that. So maybe short circuit force calculation, these things you need to do that, then you'll be able to do the substation, bus bars. When it comes about circuit breaker, concept is very clear. Okay, you need a current. Short circuit is the base calculation that everybody should be aware of it. Once you know that, you can easily select the short circuit. Then there are two important things you need to look at. One is braking capacity, another one is braking capacity, that we need to, based on that you have to choose the one. Second, when it comes about generator, your circuit breaker selection is totally different, because when it comes about generator, expire ratio will be different, right? So near, for any power plant, short circuit is totally different. When it is expire ratio will be very high when it is generator is near to your fault is near to the generator. So only for that, that specially it is available in the market, that is called generator circuit breaker, GCB selection they call it. That is totally different. So similar way, for lightning arrestor you need to do lightning study using IEEE 998, or if you are doing it the building wise IEC 62305, you have to follow it, right? So those are all we are going to cover it. I hope that answers your question, right? uh, Isolation you need to look at with respect to the safety point of view. That is very important. Yeah, Oliver, when will this webinar come back again this year? And about the price, is it compulsory to pay in once or even in the 2 or 3 times? Oliver, we are going to conduct webinar every week on Sunday. You can join, okay? But if you are going to take course, that's a different timings, okay? This webinar we are going to keep continuing it, okay? You can join anytime. Why used CVTs in 220 kVs when you are going with the higher voltage levels? You need to see and select the circuit, instrumentation transformers according to that. So there is a selection point of view. You need to different factors that you need to look at, right? So that is why in high capacity substations you need to have this CVT. We'll explain that in the course, okay? Some fundamentals you need to go through it. Simple. Yeah, hope that answers your question, Naidu. Share the PPT from this webinar session. Yeah, Samsung. Yeah, please rename yourself A366E, I guess. Okay. So those who are sharing the webinar participation certificate in the LinkedIn and tag our company name AmperePro Engineers India, so that for them recording and slides will be shared to them. Okay, so that is one thing. How to calculate NGR? Yeah, Naidu, the NGR needs to be calculated based on the LG, I mean, based on the single line to ground fault current and the zero sequence, current based on that. That is what single line to ground fault I'm telling, and based on the LV side. And that is one thing that you need to look at. Second one, when you have to, you need to see why you need a NGR. That means, let's say that in a LV and HV, in LV there are a lot of rotating motors. When something fault happens, even you can easily go and rewind it and you can pull it back, put it back. But you see it in the 11 kV. When the 11 kV, the motor capacity are so big, which is about 2.5 megawatt or 1500 kilowatt, something like that. Big motors are there. Imagine that if that motors are get failed, what happens? You cannot take the motor to the shop floor. It is so big. That is a big project. So safeguarding such a high assets is very critical. So that is why we are limiting the single line to ground fault using the NGR. So you need to select NGR in such a way that you have to limit the single line to ground fault current in such a way that it should not hit the stator, saturation, that core point. When it hits, definitely it will damage. So we need to ensure that at any point of time, the NGR is, that current should be limited. And please remember that when it comes about generator, it is very, very sensitive. They will limit to 10 ohms, 10 amps. In a mid-level voltage, I mean 11 kV to till 13.8 or something, wherein there you will limit it according to the equipment capability, maybe sometimes 400, sometimes 800, sometimes 1200, something like that. This is how you have to select, guys. Hope that answers your question, Naidu. How to select DG sync panel? Abhijit Ramesh. Yeah, DG sync, when you have a multiple DGs, and basically you need to create a panel, which means that is a simple switch gear which will have some controller, right? It is also a big switch gear. That is called DG sync panel. When you have a multiple DGs, then you need this, guys, right? why are used transformer differential protection? Okay, Naidu, let me answer this. When you differential protections or restricted earth fault protections or busbar differential protections, these are very specific to the objects. I mean, when I say object, electrical equipments like a busbar, transformer, generator, motor. When the high capacity motors are there, it is our duty to protect it. Okay. These differential protection, whenever there is a internal fault happens within the transformer, that will detect and it will trip immediately. So anything above 5 MVA, you need to provide this transformer differential protection. That's mandatory. Anything less than 5 MVA, it is not required. Cost wise, it's okay. So you can go with that. But anything above 5 MVA, definitely you need to protect. You know the cost of the transformer, 10 MVA transformer, it is very high. So instead, to protect that, you can put few more relays so that you can protect the transformer and you can sleep peacefully. So electrical engineers should think like that. In each and every point, anywhere fault happens, whether it is protected or not, you need to see it in the single line diagram. What if fault happens in this place in the bus bar? What if there is a fault at transformer terminal? What if there is a fault happens at motor terminal? What if there is a fault at that incomer, wherever the cable is connecting that point? You need to think, and accordingly you have to choose the protections, right? Great. I would like to know whether this course concludes detailed training on power system studies such as load flow, short circuit, harmonic, relay, coordination, arc loss analysis, transient stability. Could you please share the detailed syllabus and explain coverage? Samsung SM, we are going to touch that. For that power system study, we are going to come up a dedicated course, because I don't want to mix with that. This is engineering, that is study. Okay, this is engineering, that is study. So the study we need separate. We wanted to have a dedicated one. We are going to start very soon. That also will announce. Okay, great. But of course, both are linked. Both are linked. We need to see it, and sometimes both, if you know, that's a huge advantage. What parameters are considered to be NGR? Yeah, I have recently concluded that NGR calculation. Please visit our website. You can buy that course, Naidu. Wherein I have discussed in detail. I have talked about system earthing. What is solid earth system? What is ungrounded system? Why ungrounded system is not used? And what is NGR? In that, what are the difference? Low impedance, high impedance, everything I have discussed. So I guess you can visit our website. You can buy it. It's just 2,000 rupees. Okay.